So we have a very special webinar ahead for you today, and it features three subject matters experts engaging in a roundtable discussion. And it's about transforming healthcare and pharma with graph, database, and analytics. We hope that you really enjoy our discussion and find it informative. I'm today's host. I'm Chris Primesberger. I'm editor-in-chief of eWeek, and I totally enjoy writing about topics like healthcare IT and graph database. So this is particularly attractive for us because I know our readers want to know more about these things. Our panelists today are experts, starting with Dan McCreary, who's a distinguished engineer in AI and graph at Optim, which is a healthcare provider, software provider. John Herkie, who is director and technical evangelist at TigerGraph, which is our host today, and which makes a very impressive graph database. And finally, Noel Gomez, CEO and founder of Convexa, where he had, in the pharma business, he had 10 years at Amgen, where he was a data sciences lead, and he also has a lot of other impressive background traits. So thank you all very much for coming. And I think we should just jump right in because we're running a little behind schedule. We should really just have a quick definition of what a graph is, and just in case some of our listeners don't know what that is. Who would like to go ahead and just give us a quick overview of graph database?
I'll give you a quick one. This is Dan McCreary. I define it as usually an in-memory database where business entities are captured in terms of something called vertices, and their relationships are classified in edges. And I think the big thing that we're seeing today is that because these graph databases are implemented in a native format, they use pointer hopping traverse relationships, so there's no joins. And so there's no penalty for doing really in-depth queries, and that's really transformative when we have clinical data, especially, and any healthcare data that has lots and lots of relationships that we want to analyze in real time.
Okay, very good. Yeah, I appreciate that. I think this is particularly valuable when it comes to medical records and security of medical records, and I think we'll touch on those subtopics also as we go along here. So Dan, how do you see your role real quickly at Optim?
Yeah, I work in a group called the Advanced Technology Collaborative, and my role is to look at the landscape of emerging technologies and help our business units find the right technologies that fit their problems. And Optim is typically been known as a very strong analytics, but doing a lot of stuff with provider and claims. And we're just in the last couple of years really getting deep into the clinical space where we're analyzing a lot more integrated healthcare records. And those records have an amazing number of relationships between a patient and their conditions, the drugs they're on, their symptoms, their diseases, their immunizations, all those things are captured as relationships. Right. And what we found is that we just could not analyze that data in real time, especially at the point of care, unless we had it all running in a graph database. And so my job is to really look out for those technologies and figure out where the good match is.
Okay. John Herkie, could you describe your role at a high level for us?
Yeah. So actually, Dan and I were working together for the last couple of years before I made the jump over to TigerGraph. And so I was I would say a senior graph engineer, maybe. I would be the one that was actually implementing the enterprise graphs and modeling and doing the data loading and configurations. So I have
testing too, John.
Well, yeah. Yeah, a lot of performance testing too, because it's one thing to say that a graph can handle X amount of nodes, and it's another to actually test it and stress test it and try to break it, and make sure that the claims are actually up to what they say. So did that for the last 2 years. You can see my bio for the other things I've been involved in and are involved in. But more recently, I came over to TigerGraph to help spread the love of how to implement Graph and how Graph can make an impact in your businesses. So that's a short bio of me.
Good. And Noel, you're a CEO and a data science person at the same time. How is that possible?
Well, I was a data science person first, and now trying to start a company. So what I've been looking at Graph for a long time. So I've been looking at the Graph space for 3-4 years now, and started out by seeing news reports of things like the Panama Papers and how different entities were linked, and then I saw the connection between that and all the healthcare data, the pharma data that I was exposed to. So how doctors are connected to patients and claims and prescriptions and all the different types of entities that exist within a pharma organization, and trying to see how we can use the Graph database to extract new and different types of insights. Since then, I've also explored things like how can a Graph help in a virtual assistant, which is what I'm doing right now. So if I have this doctor connected to these different entities, can I ask questions and derive insights without having to explicitly join many tables that you would normally have to do in a relational database? So that's another area that we've looked at. And finally, another project that I've been exploring is how can a Graph database help with metadata? Because in a lot of large enterprises, there's tons and tons of data, and it's spread out in many places. So can you create a metadata graph and use that to find your data and your insights and every piece of metadata that surrounds the data that exists within an organization?
Yeah, that's interesting. We should definitely talk about metadata graph databases, because that's something I haven't really even written about. So I'd like to learn more about that myself. But in the meantime, the first question is, why would we want to store medical data in this kind of a graph? I mean, I think I know, but I wonder if our readers or if our listeners do. And also, I want to remind listeners too that we're going to have a question and answer period, maybe in about a half hour or so, at the end of the discussion, so that if you are thinking of questions that you have for any one of our experts here right now, write them down, and then when the time comes, we'll have you send the questions to us, either verbally or text. I'm not sure exactly how we're doing it, but one way or the other, we'll let you know. In the meantime, I can definitely see, and Dan touched on this a little bit, Dan and John both touched on this a little bit. I mean, a graph database is all about relations between data. Data that's related, that touches each other, that can connect, and therefore is more available in real time, because there are already paths there that can be followed to find it and bring it up so that it can be analyzed or used in some other way. There's a natural fit to a graph that deals with the relationships in medical data. Could we expound a little bit more about that? Any of you right now, if you want to just take it as a toss-up question, go for it.
Well, I'll jump in. I always have a lot of strong feelings about this, so I'll always chime in on this. And I think the biggest thing that I have learned about studying the shape of data in different industries is that clinical data for our applications, as I mentioned, has lots of relationships, but there's also a hidden complexity, and that's what I call high variability. High variability means that every one of your patient profiles may have different data sets that are relevant. And if you think of a newborn baby in a neonatal care setting, or a pediatrics children's hospital, or people that have polychronic conditions, many complex conditions, or people in senior living where you're looking at activities of daily living, every one of those cases has dramatically different data sets that are loaded. And even within those data sets, you see variability. And when we've tried to load and do analytics on this in relational databases, we can do it as long as we have a huge amount of horsepower. Very, very large databases, custom hardware around that data, and then we can only do it on a small sample population. I think what we're seeing about modern in-memory native graph databases is that we can go to the billions or tens of billions of vertices and still get good real-time performance. And that's something, if you ever tried to do joins on tables that have billions of rows, you're just going to get minutes to respond even with simple joins. So what we see is that we're at the enterprise level, and this is not just small projects, but really enterprise scale. We get performance that's very, very consistent, even though our data is growing. And the most important change is that graphs have now become distributed, right? They're not locked into a single node, a single flat memory space. They can, as you add more data, you add more nodes to cluster, and you don't have to change things. And that's really made a huge difference in the productivity of our developers. All right, I'll stop now. Go ahead, anybody else?
Yeah, who'd like to step in?
I guess I can. So the question again was why store data in graph? Is that correct?
Yep.
Yeah. So I have a personal story I wanted to share with you. Why graph is important to me, and this goes into why store data in graph. My mother was recently within the last couple months diagnosed with cancer, and it's hard to deal with, and there's a lot of things that in the healthcare space that could be fixed to help people that are going through this, either preemptively detect things that might lead up to cancer, or best ways to help them once they are diagnosed with cancer. So one of the reason I bring this up, why store data in graph, is really when I was there at United Health Group, and the things that we did with the graph, we're able to join data that you would never have joined, from claims data to FDA data to drug data, from inner data to outer data, and able to piece all these pieces together to be able to find the best drug treatment path, or the best treatment path for you as an individual based off your demographics. And this is only something that can be actually accomplished when you're able to stitch together all this data across claims and across demographics and across state and across federal and across all these things that can come together and be stitched together to tell you like a holistic picture. And so if I was to say why to store data in graph, it's really to actually put that whole picture together, so you can especially in the healthcare space, so you can more effectively treat the patients. So I guess that would be my why store data in graph. One of the reasons.
Okay. All right. Yeah. Each of you, if you could just identify yourself, before you make a statement, because sometimes we don't know who's doing what. So I believe that was Noel there, and
no, that was not.
That was John. That was John. Sorry, I do apologize.
Oh, okay. No, that's okay. Even your host is confused. So sorry. So sorry about that. All right. Do we want to add anything else to that question before we go further? I mean, that's a pretty basic one there. It's all about data relationships and moving across different genres of information to bring it to use, correct?
The way I've always seen it is that there's sort of two pieces. One is, let's say, the ability to do something. And so what we just heard about was the complexity. It's possible to do some of this stuff in a relational database. It's just very complex. But I think the other piece of that is the knowledge that you need to know to do that. So in order for an average analyst to pull out all this information, and especially when they're going across many tables, many types of entities, many systems, the complexity grows exponentially. And so how can that user really have that total understanding of how to get from A to B or A to Z? It's very difficult. Whereas with a graph database, you're embedding that logic as you're loading the data. And so from the end user's perspective, they just need to know where they're starting and where they're ending, and how they get there is not something that they necessarily need to worry about.
Mm-hmm. Mm-hmm. Yeah, the whole idea of simplifying all of this is a key factor here. What about queries? Are queries easier to use? This is just the journalist in me talking, or asking the question as a toss-up to any of you. Are the queries generally easier in a graph database than a relational, or what?
I think the problem is the maturity of the ecosystem. There traditionally hasn't been a standard. So we think in a relational database, pretty much SQL is standardized across different database providers.
Yeah.
And so if you learn that, you can pretty much work in any database. And that's part of the maturity, right? That's been defined for, tens of years. I don't know, I think it's in the 70s or something like that, where that SQL was first created. We're in the graph space, because it's still an evolving technology, we haven't quite gotten there. I think the industry is moving in that direction. But there's a learning curve. You can't just say, oh, I know SQL and all of a sudden I can use graph. No, there's going to be a learning curve, and depending on which database engine you're using, it's going to vary.
Right. Okay. What are other challenges are graph databases helping solve in this field that we haven't talked about? Are there any one or two that we should touch on before we move on to their opportunities?
I think in healthcare, one of the biggest use cases that comes up over and over again is fraud detection. And the metaphor that I like to use is fraud is how deeply you can look into the connections of your data at scale and find certain patterns that are irregular, and what algorithms can help you discover those irregular patterns. I think the general rule of thumb is the more data you connect, the more patterns you can detect, and you can find out what normal is. And there are a lot of graph algorithms to look at what normal relationship counts and things are. And in the provider space, what are the types of procedures that a provider typically does, and how often do they do them and things. When we start to see fraud, we start to see variations in those patterns. And if we don't have that data all in one spot and connected together, it's much harder to find out irregularities. So I think fraud detection is something within healthcare that graphs are ideally suited for. And there's a ton of material out there about using graph databases for fraud detection.
Right. Yeah. And I mean, you can't have too much good security. It's impossible. And to be able to use artificial intelligence and machine learning in this setting is an incredible advantage to a company to be able to do that. What are some of the other ways that a graph database uses intelligence and machine learning? Obviously, fraud detection is a big one, but are there other areas in which those can be plugged in?
So I guess the question, how is AI and graph is being used? Is that
right?
Okay. Yeah, I can take that. So this is John Herkie again.
Hey, John.
Nice to see you guys. So the ways that graph and machine learning are being used is, if you're familiar with what machine learning is and how it's currently used, is you do feature set extraction. And so you grab attributes around some of the data that you're collecting and use these attributes and you create a model. And so in the graph world, there are a couple different advantages that you can do. One is when you have your interconnected data, you can actually derive attributes internally in the graph. So you have all your data interconnected. You can run algorithms to determine. We talked about sort of PageRank. I don't know if we talked about PageRank, but there's different algorithms like PageRank, cosine similarity, when you're trying to find patterns of communities, and you can bring these together and create attributes out of the graph data. And then you can feed those attributes along with the typical feature extraction and feed that into a machine learning model. That's one way I've seen it. So you're actually taking the feature extraction straight from the graph and running it through your TensorFlow or Keras. The other thing that is more recently being explored is a concept called graph convoluted neural nets. What these are about is looking at the structure, the shape of the data and how it's interconnected, and feeding not just the features, but feeding the actual structure of the data through your neural net. So the easiest way to describe this and how I describe it to the students I teach is imagine like this palm tree. The palm tree has got green leaves. It's got a brown trunk, and you can describe the attributes, the green leaves and the brown trunks. But imagine now the palm tree is just stripped, and it's just an outline of the palm tree. So you can detect that it's still a palm tree just by the shape of the feature, without the actual attributes in it. So one of the attendees also on this meeting, I see, Parker Erickson, has implemented a solution like this. And if anybody wants to explore it and get their hands on, I can pass some notes along. But what it allows you to do is have you can even test it on a lower sample size. So even if you don't have a huge sample size, the accuracy of just looking at the data and how it's structured was able to bring the result accuracy, I think, to about 86% in this fraud use case that Parker was using. But yeah.
Yeah, this is Dan. I just want to second that. I think the summary that I like to say is that very often machine learning models look at the properties in detail, but they don't look at the structure of the relationships. And what we find is that structure often informs insights. And that's often left on the table in a lot of traditional machine learning applications.
Structure informs insights. Can you just go a little deeper into that, what that means, Dan? That's an interesting statement.
Yeah, there's an entire branch of machine learning that really is focusing on using structure analysis, the structure of the graph, the relationship between things, and extracting features from that. And one of the best examples is fraud. If you look at fraud patterns in the financial industry, you look for money that's being laundered. It often has these loops in a graph where you're going to transfer money from party A to party B to party C and then back to A. And those loops are effectively a structural aspect of the graph. And you can only detect that by doing traversals of a graph, not by a single property, the person's zip code or those things. It is really structural. And what we find in healthcare is that many of those structures are about how patients are related, right? If you just look at the flat things of patients, you don't really understand the relationships. But if we go through the graph, we have a graph of their conditions and symptoms and drugs, traverse those to find other patients and see what their outcomes were, then that structure informs you on how you can best find care paths for that patient.
Got it. Noel, how does this work in the pharma business? How does AI and machine learning connected with a graph database help you do your job at your company?
Yeah, so some of the things we did are similar to what was just described. So you're looking for community detection. You're trying to find groups of physicians that are similar in some ways, that prescribe similarly, that have patients with similar conditions and things like that. The other thing that's possible to do is create features that would be more difficult to do in a relational database. So these are things like figuring out which prescribers are referring patients to other prescribers. So how are those people connected? And then using those connections to figure out the page rank of a doctor. So which doctors are the most connected or the most influential in your network. So those are the kinds of things you can do.
Okay. Very good. That's good, because it wasn't clear to me at the time, and you've done that. Thank you. Appreciate that. We've got about maybe 22, 23 minutes left in this, and about half of that time I think we're going to make available for questions. But let's talk about the future and the potential of graph databases. What are some of the things we might be doing a year, 2, 3 years from now with graph databases that maybe we're not doing now? Because like I think Dan said earlier, or John, maybe both of you said, it really is kind of a new area. It's growing. And there's always growing pains with any new product in any new sector, and it's feeling its way along right now. But I think there's a huge future ahead. What can we expect? It's a toss-up question. Whoever wants to go for it.
All right, I'll jump in. This is Dan again. I think one of the interesting things about the future of graph is trying to predict the insights that you'll be able to have by having 10 or 100 or 1,000 times more data connected than you've ever had. And there's an entire field of mathematics and physics and other areas called complex adaptive systems. And complex adaptive study scale laws of as things get connected, how do you predict those things? And I think the summary that we have found is that as we have grown from 100 million vertices to 1 billion vertices to tens of billions of vertices, that every time we grow by an order of magnitude, there are new insights that we really didn't anticipate. That is, we cannot predict the insights that happen as our graphs grow in an order of magnitude. And the difference that we're seeing in the past is that in the past, when we used the graph databases that were limited by how many vertices you could have in a single processor in-memory model, that they would frequently, we'd had a lot of pilot projects and they would just stop working because the query performance would just drop to the floor as the nodes didn't fit into the memory. But now what we're seeing is high memory systems as well as distributed systems where you can have those queries can span multiple nodes. And we're not really limited anymore. We can take every touch point with our customers. Every time they visit a website, every page they visit can be summarized in the graph. And we can use those insights, every touch point, to predict for our customers what products and services are most suited for their background based on similar ones. So for me, the amazing thing to see in the future is as companies build these enterprise graphs, what new insights they have about how they can serve their customers better. And I think the thing that there is to really look for some of the complex adaptive systems things to try to predict what is the value of an additional data set. And remember, this is Metcalfe's law, right? Every use case is going to be easier if you have all this data already loaded into the graph. And every new project will have a much smaller percentage of new data. And so the value of that enterprise graph is really related to the number of business units that are contributing data and getting insights. And that's that critical mass that I think we'll start to see in the next couple of years.
Yeah, predictive analytics, we're seeing that area of analytics really get a lot of attention, a lot of interest. And there's no question about it, with the amount of data that we have today, and only more and more is coming in. It's not going down anytime soon. The predictive analytics are a definite possibility. John and Noel, what do you think about the future?
This is John again. I was just going to add on to, just to add some clarity to some of the things that Dan was talking about with having all the data in the graph. It's not, if you think, the best way to describe this would be, everyone has a cell phone. You can take a picture, and when you take the picture, there's the picture, but then there's also all the information about the picture. You have when it was taken, who took it, what time it was, where it was, and all this metadata right? Now imagine you have that picture and you send that picture to somebody else. You're going to capture, there's going to be a relationship between you and this next person. And so the picture was sent to Joe at whatever time. So when we talk about having all the data in the graph, it's not the picture itself, it's all the data about the data that interconnects the data. So it'd be all the metadata. When somebody visited a doctor office, or when somebody made a call in, when somebody had an x-ray, it might not be all of the data about that thing stored in graph, but it's the metadata about it and when it happened, and all the, maybe even to the level of feature extraction. We talked about chatbots. So when you're doing chat, maybe the vocabulary, the nouns are in graph and interconnected to all the actual text is different, or in a different place. So it's sort of this abstract layer that can stitch together everything, but it's not where all the data resides in the graph. I just wanted to make that clear because it's a common misconception that everything just goes in the graph. It's the data that connects the data and the important data that you want to extract and put it into that sort of the mesh network. But going back to the future, knowledge engines, as chatbots come into everybody's house and we're asking questions to it, that's going to be having probably a graph knowledge engine in the background that's interconnecting all the different answers. You're using graph every day, and you probably don't realize it when you're using Google or Amazon or Netflix. They're all recommending and stitching together profiles about yourself. So I think, yeah, as data gets more complex and more data comes that needs to be joined up to derive insights about whatever the domain is, I don't see any slowing down in the graph space. And hardware acceleration, I don't know if we talked about that, but custom hardware, that's just like when AI started to get big, they had GPUs that sort of accelerated some of the AI field. There will be probably more custom hardware that's built to accelerate the results of graph. So that's one thing to look out for. Yep.
Yeah, and I was going to add on to John's thing that I'm going to have a story in eWeek later today about a new file system just for solid state IT, for solid state storage and servers. And it's custom hardware. And as we go along, like you say, custom hardware is going to be designed for newer technologies like this graph database. So it's going to be real interesting. Noah, what's your take on the immediate future of a graph database?
So I think there's going to be a couple of different things that I see happening. One of them is, I think there is going to be a consolidation of query languages, so that'll make it easier for people to adopt the technology. There is and there's going to continue to be increasing competition, which will help the industry mature some more. And I think, you know, to talk about this metadata and the chatbot stuff that we've been referring to, we actually see that happening as well. So I don't know if everybody saw that Google had a Super Bowl commercial where they were showing how they were the Google Assistant was remembering information about this person in the commercial. And that's where now you can start saying things like, John is a vegetarian, or remember that John is a vegetarian, and then you can imagine asking a question like, what kind of food does John like? And the engine being able to reply with that. So I think once these technologies are available in the mainstream, we can do that in an affordable and scalable way. And so it opens up a lot of possibilities in sort of creating this cognitive knowledge engine that you can use to answer these kinds of questions.
Okay. All right. Well, we've got we got about 10 minutes to go in our discussion. And if anybody out there has questions for our experts, go ahead and send them in to us, and we'll take a look at them. And in the meantime, I would like...
I think we
go ahead.
2 questions out there on the question board. So I wanted to repeat those so everybody can see them, and then maybe I'll take a swing at the first one.
Good.
So the first one is, how do graph databases work with relational databases? Can they be joined? And one of the things that we have been doing quite a bit is we think of most of the systems that are gathering information as what we call operational source systems. And a lot of them are commercial products that run on relational databases. But what we have been doing is we've been building what are called change data capture streams. There's a technology called Kafka, and Kafka allows us to put the changes in those relational databases into these streaming interfaces. And the graph just consumes. They actually do a subscription to say, these changes in these relational databases are relevant for me. And most of those streaming systems, they're not batch overnight anymore. Within 60 seconds of inserts, updates, or deletes on relational, they flow into our enterprise graphs, and they're accessible to our call centers. And so I think the key thing about this is that you need to be able to get the data out of relational very quickly and then get it into your enterprise knowledge graph, and getting away from the old batch processes is critical. Once the data is in the graph, they can be, quote, joined together. We actually don't really call it joins, we just call it pointer hopping. And then you can have an integrated view of your customer for all that data. So I hope that answers the question, and I'll let somebody else take the next one.
Okay, go ahead and read it.
We were talking about how data and the queries can all run together without slowing the system down. And as we implement these systems in production, where we have a service level agreement, so for example, a customer service screen has to render in 100 milliseconds. How do we mix those constraints with these deep analytical fraud queries that may take a lot of resources and run for a long time? Can they share the same server, or do we have to have two different servers to run those on?
I can attempt to take this one. This is John again. Just off the top of my head, I would say you'd want to specialize your servers for the specific use case, and sometimes a one size fits all isn't the best way to go. You'll run into some limitations one way or the other. So to really to answer your question, I would try to tailor, if you're going to do really deep analytics that are really going to be going through multiple hops and hops and hops and hops, that will, for the most part, consume a lot of resources. That probably isn't going to be the best use case to have that running at the same time you're doing a production system that's maybe the doctors are talking to the patient in real time and you need that data quickly like this. So I would think about from a solutions architect standpoint is I would probably, in this case, break out those two systems and to have one system that's sort of for the analytics, and have another system that's for the production use case of joining maybe a member journey or whatever that domain is. Hopefully that answers the question. If you want more deeper insights into that, we can have a discussion later if you have a specific use case.
Are there any other questions, Ed?
I think those are the only two questions. I just wanted to just add a footnote to John's, as I agree with John completely that if you have different loads and SLAs, sometimes you really have to protect your primary production system that has service levels and separate the deep running analytical queries. One thing I will say though is that I always try to remember the rule of 5 orders of magnitude here, right? So if you have a query that used to take 8 hours to run, those queries can in fact run in less than 30 seconds on a lot of these things. And we call these HTAP, the hybrid transactional and analytical systems. And because we don't have the join penalty, these queries can run. So I think there is a gray area in there where people are in fact putting lightweight analytics more on these production servers. And some of those, for example, are patient similarity calculations. we are offloading those into custom hardware, and those can now be part of that production interface. So the line is getting gray, and in between short SLA queries and deep analytical, and I think they'll continue to blur in the future as we get better hardware and better distributed processing.
Mm-hmm. Anybody else have anything to say about that?
I think in general that the future is probably a combination of relational and graph because they do have their niche problem that they're solving. And like I said before, the relational space is so much more mature that in certain instances it may make the most sense. So I see it's a combination. It's probably a hybrid approach, and that's where things have to go. I think so better integration and a simpler user experience across both of those technologies.
Yeah, it's kind of parallel to Wi-Fi and 5G. And we just had a story about that in eWeek. That's why it's fresh in my mind. Wi-Fi is not going to go away. Some people have said that's going to happen. It's not going to go away. It's going to coexist with the new spectrum. And it's just like this. I mean, these are all going to coexist. They all have their jobs to do and their use cases that they're best at. And so that's it. We only have a couple minutes left. Could each of you maybe just give me a takeaway sentence or two from this that you think our listeners should take with them today about graph data?
I just want to answer the last question. There's one more question that was asked.
I didn't know that. I didn't see it. I'm not looking. I can't see that. Go ahead.
That's okay. So the question was, do all graph databases require message queues like Kafka? Do you have other options for other than Kafka as far as I'm guessing how the data gets into the graph? There are numerous ways. We have you can use I guess talking about tiger graphs specifically, if we want to talk about that, or if we're talking about general graphs, tiger graph has S3 connectors. You can connect to use a JDBC driver to connect with Spark. You got Hadoop. You can connect there. It has natively built-in REST services, so you can actually just like normal post data to the graph. There are some community connectors like Python. There's connectors to do RDB MS, and then of course Kafka. And the other one that isn't we've done before is we have data loaders and we use Jenkins, and then we have a Gradle component that actually would execute a load. What this would be used for is if we had like a hot drop zone where you're dropping files into maybe a shared box, and then you can grab those CSV or JSON files and push them into the graph. So those are some ways that you can get the data into the graph. If hopefully that answers your question.
That's useful information for sure. Have we exhausted all the questions?
Yes.
Yeah. Yep. That is it.
You guys each have a takeaway that you could tell our listeners about from this today?
My takeaway is I hope some of you or all of you are excited to try it. And if you are, I'm here for you to help you on your journey. And I look forward to talking to each one of you. And if you're just graph curious or want to know more information, don't hesitate to reach out to me. My name is John Herkie. You can reach me on LinkedIn, and I'll answer any questions you have.
Good.
This is Dan. I think my big takeaway is that I think graphs are going to be part of the solution space that all solution architects that are looking at business problems need to consider as part of their solution sets. So I think all solution architects should educate themselves on what graphs do well and what they don't do, and then make sure that you're giving objective recommendations to business units that are coming up with new challenges. And I think graphs just fit into a lot of use cases where integrated data and relationship data are essential. So I hope everybody keeps an open mind about using those processes.
Mm-hmm. Noel, do you have a takeaway?
Yeah, I think it's even when I started down this road, I kind of fell in love with graph and thought, we can solve everything. And at the end of the day, I think it's really about finding the right use case for the technology and making sure that you understand the limitations, as was said before, and really understanding, what you can and can't do. And so having that final endpoint, what are you trying to do? Certain use cases like fraud are very easy to understand and everybody gets it. But when you're in a less defined industry, that use cases have to be well defined first, and you have to find the right people who can understand that business value before you jump into the solution. Very
good. I want to thank everybody on the panel today. And for bearing with us, for being a little late on getting started. But I think it was a really, really good discussion. I learned a lot. I hope you all did too. So I want to thank Noel Gomez of Convexa, CEO of Convexa, John Herkie, the Director and Technical Evangelist at TigerGraph, our host today, and Dan McCreary, who's a Distinguished Engineer in AI and Graph at Optim. Thank you all for participating and giving us your time today. And to all of you out there listening, thank you all very much. Until next time, have a good day.